So given that the tank was full of water when the leaking started, where our differential equation is given by this, where k is minus 0.1 and h is the height, solve the differential equation with your value of k being minus 0.1 to find the value of t when h is 50. Okay, so first thing we have to do is pretty much figure out how to solve this differential equation. Well, the key idea is that we need to move all the h terms with the dh and all the t terms, or well in this case, non-h terms, to t. So let's go ahead and move this equation. So what we could do is firstly times dt across and divide by h minus 9 power half. So we should have dh over h minus 9 to the power of half. And because we got h and dh in the same place, we can now pop in the integral sign. And same thing here. So now we got k times dt, and k we know is negative 0.1. So I'm going to go ahead and write that now. So this would be negative 0.1 dt. And I can just put an integral sign here, plus c, because this is just a constant and integral dt is just t. Now let's do this. So how to integrate this bottom equation? Well, if you're not sure, I would just use substitution. So let u equal h minus 9. So on the side, little working out. So just say let u equal h minus 9. Therefore, du equals, and then differentiate this, will give you dh. Easy stuff. Not bad. So now all you have to do is really know is that we can replace h minus 9 with u and dh with du. So nothing really changes. So now we got the integral of, and I'm going to make this 1 over u to the power of half du. And just rewriting this again, this can be same. This is the same as u to the power of negative half, because you can just raise the power up and put a negative sign. And this is going to equal to, and the right hand side would be minus 0.1, and integral dt would just be t, and hence plus c. Now evaluating the left side, integrating this one is easy. You just raise the power up by 1 and then just drop it down. So it's just going to be power of a half over half, which is the same as 2 times u to the power of half. Okay, so far so good, not bad at all. Now, one thing we have to really spot is this sentence here. So remember it says, given that the tank, oops, wrong one. Given that the tank was full of water when the leaking started, so that tells us like, because the tank was full, it was at a height of 200, and this began as soon as the leaking started, and this would be at time 0. This is just the initial point. So let's plug in these values here, because then we can actually find the value of c. So when t is 0 and h is 200, so when h is 200, this means u equals 200 take away 9, which is 191. So we're going to have, therefore, u times, and the power half makes it square root of 191 equals minus 0.1 times 0, which is going to give us 0 plus c. So therefore, c must be 2 root 191. Let me see if I can simplify that, but I don't think I can. Nope. So c is 2 root 191. Okay, good. Now, rewrite this whole equation now back in. So we're going to delete all of this. Delete. Okay, so this can give us plus 2 root 191. Okay, so almost done here, guys. Almost done. Okay, so now all you have to do is literally plug in your other initial condition, which is the value of t when h is 20. So that's fine. This is actually the easy part. This is just simple algebra. So when h is 20, this means that u is going to be 50 take away 9, which is 41. So we're going to have 2 times the square root of 41, because u to the power half, equals minus 0.1 t plus 2 root 191. And just a quick little algebra, and making t the subject, you should basically subtract 2 root 191 across and divide them by 0.1. So something like this, minus 2 root 191 over negative 0.1. You should get a t value of 148 to 3 significant figures.